next session of quantum computing. Here we are going to discuss about quantum kernel methods. So the lecture outline is quantum kernel methods, classical kernel methods of quick recap, and quantum feature maps and kernel estimation, quantum kernel algorithm, and the steps to be followed by quantum kernel algorithms. Quantum kernel methods that is used in quantum computing to enhance the traditional kernel-based machine learning techniques. So quantum feature map is to be used to map the classical data into high-dimensional Hilbert space for better classification and pattern recognition. So the limitation of classical kernel methods here is computationally expensive for high-dimensional data, may fail to efficiently capture complex data relationship, and we may have a different kind of advantages are also there in quantum kernels. Quantum computers can generate feature maps exponentially large in size. The second is potential to outperform classical machine learning for certain problems. Example, quantum advantages in classical task. Classical kernel methods, a quick recap. In traditional ML, kernel methods are used in algorithm like support vector machine for nonlinear classification. Kernel trick here is instead of explicitly computing feature transformation, we can also go for inner product in high dimensional space. So example, Gaussian RBC kernel and polynomial kernel, sigmoid kernel. So mathematically we can represent as k of x comma x prime, which is equal to phi of x transpose and phi of x prime. So where k of x comma x prime is the kernel function and phi of x is the feature mapping. Quantum feature maps and kernel estimation. Quantum feature map is used here. Use a quantum circuits to transform input data into quantum state. So example transformation is ket x, which implies u of x ket 0, where u of x is a quantum circuit encoding input x into high dimensional Hilbert space. The next is kernel estimation using quantum computers. Compute quantum kernel via inner product of quantum states, transformed data points k of x comma x prime, which is equal to determinant of phi of ket x and phi of ket x prime square. So this is the transferred transferred input we need to consider here, and we can achieve an exponentially large features space using polynomial number of qubits. Quantum kernel algorithm, we can have many steps are there. The simplified version here is data encoding. Convert classical data X into quantum states using quantum feature maps. Quantum circuit processing, apply quantum gates for entanglement and transformation. Quantum kernel computation that measures overlaps of quantum states to compute kernel values. Classical ML algorithm use kernel values in support vector machine, or another ML method is for classification. So quantum versus classical kernel complexity here is, first one is feature mapping. We can go with classical kernels. Mixed and RBF polynomial methods are used. For quantum kernel, quantum circuits also to be used for flexible. And next feature is computation, polynomial scaling. Potentially we can, in quantum kernel we can go with potentially speed up nature is there. For kernel matrix size, order of n squared for n data points, and for quantum kernel we can go with quantum computation. So quantum kernel method in practice, we can train the SVM model using quantum kernel values. Steps, the first one is encode data using quantum feature map, compute quantum kernel matrix using quantum processor, and we can go with classical SVM classifier to make prediction. So for the use case, we can go with the finance and healthcare, cyber security, chemistry and drug discovery. So for the finance, we can go for fraud detection using complex transaction data. For healthcare, medical diagnosis with biological patterns are to be introduced, and for cyber security, anomaly detection in network security. For the chemistry and drug discovery, analyzing the molecular pattern and interaction also to be introduced. Real-time example of quantum kernel methods is handwritten digital classification for eminent using quantum kernel. So this is a one kind of data set, we can go with that. So the problem statement related to this quantum in this eminent data set is consist of handwritten digits 0 to 9. The goal is to classify them correctly using quantum enhanced support vector machine SVM. Traditional machine learning techniques such as classical SVM require complex feature transformation to separate digital classes effectively. Quantum kernel methods offer an alternative by mapping data into high-dimensional Hilbert space using quantum circuits. So this is a very traditional approach of SVM implemented here. So first we are going to import the packages related to um, SVM, and data set is also to be included. Matplotlib library file also included, and with the functions we are adding the samples and noise and random status also to be selected, and we are going to call the model and we are going to fit the model, and with the help of that we are going to use model prediction, and we are going to reshape the prediction models. So with the help of that we can go with the scatter plot. So with that idea we can easily classify the data inputs. So this is a very traditional method, but we can go with a different kind of kernel method also to be introduced. Already these things are discussed later. Thank you learners. We will see in the quantum SVM demo in the next session.